Our last example is trying to solve for a starting value, and we'll talk about what that means. So an investment account currently has $2,600 and has been growing at a rate of 4.5% over the past 12.5 years. So we have our rate. I'm going to go ahead and write that down. Our rate as a decimal is 0.045. Our time increment is t, 12.5. We have those two numbers. And now we have this 2,600 and it says currently. So you might think that's your principal, but you need to read the problem carefully. It says how much was in the account at the initial start of the investment. We want to actually find what the principal is. We have the final amount. So we actually have to work backwards. So think about your formula. This is a growth problem. A equals P, 1 plus the rate to the T power. We have our final amount. We have our rate. And we have the 12.5 in for our T. Now we have a few ways to do this. First, let's combine the 1 and the 0.045. So 2,600 equals P 1.045 raised to the 12.5 power. Now, if you're trying to solve this using an equation, you can actually figure out what is 1.045 raised to the 12 or 12.5 power. And you end up getting 1.7336188900022. So you could actually just say 2,600 is P times that number, and then at the end divide to solve for P. And so I think most people probably prefer that method. So I'll show that method first. So again, that's going to be, let me move this over here so I can see both of these. This number right here, using your calculator, is I would go about 4 decimal places out, so 1.7336. And then, so that makes your equation look like this. It's basically 2,600 equals P times 1.7336. And that's just a quick division. So if you divide by that number, both sides, you'll get your starting amount. So let's go ahead and do 2,600 divided by that number. And it looks like we started about 1,499.76, roughly $1,500 is your starting amount. So I'll just round that to 1,500 since these can be a little bit all over the place, especially how you round. But P is approximately equal to, I'll put a little approximately equal to $1,500, give or take a couple dollars depending on how you round. So that's one way to do it. Another way to do it would be to use your intersections or guess and check, but you could do y equals 2,600. Well, let me actually do this first. So let's call x our p-value. Let me go home here. So this is, instead of having the x in the exponent, we know our x value is, our time increment is 12.5. Let's call our x the p-value. And then you could say 2,600 here, y equals 2,600. And if you did that, then what you would have to do is you would have to scroll up again and find the intersection. Let me zoom out. It's going to take you a little while because 2,600 again is up there. But you can see the flat line at 2,600, and this is actually not an exponential curve, it's just a line because we've already put the exponent in. But it does meet here at about 1,499.753. So that would be the exact answer, $1,499.75. But I rounded to $1,500, which is fine. So that's another way to do it too.